Hi everyone, welcome back to Quantum Hub Science. This video will discuss about IGCSE Chemistry Chapter 1 States of Matter based on the newest Cambridge IGCSE syllabus for this year. So let's get started. As we all know, there are three states of matter in general, which is solid, liquid, and gas. Matter is anything that has mass and takes up space, and it exists in one of these three states. Now, let's discuss the characteristics of solid, liquid, and gas from this table below. So this is the structure of solid, liquid, and gas. Then how about the particles arrangement? As you can see, the arrangement of particles in solid are in a straight regular arrangement. Every particle in solid are very neatly arranged between one and another. While in liquid and gas, the particles are randomly arranged. Now let's see the distance between particles. As you can see, the distance between particles in solid are very close each other. In liquid, the distance between particles are still close enough, but not as close as in the solid state. While in gas, you can see if the distance between particles are very far apart. Since there is a lot of space between the particles, gas can be compressed into a much smaller volume. Now let's talk about the particles' movement. In the solid, the particles can only vibrate in a fixed position because there is no more space to move. In liquid, the particles still can slide over each other because it still has a tiny space to move. In gas, the particles can move randomly and quickly in all directions. Now how about the energy level? Energy is produced when the particles is moving. Since solid can only vibrate in fixed position and cannot move freely, that's why the energy in solid is very low. In liquid, it has greater energy than solid because the particles still can slide over each other, while the greatest energy is produced in gas because the particles in gas can move randomly and quickly in all directions. Now let's talk about the state changes. Changes of state can happen when particles gain or lose energy. The state changes from solid to liquid is called melting. From liquid to gas is called boiling or evaporation. From gas to liquid is called condensing. From liquid to solid is called freezing. From solid to gas is called sublimation. While from gas to solid is called deposition or desublimation. And there is an increasing of energy from solid to liquid or from liquid to gas. One example of energy is heat. So that means if you increase the temperature of a solid, it will turn to liquid. On further heating, it will turn to gas. So these will have reverse effect if cooling or decreasing the temperature. Now let's see how is the effect of temperature to the state changes of solid, liquid, and gas. In solid, the particles are in a straight regular arrangement. They are very neatly arranged between one and another. Heating a solid over time will cause its particles to vibrate more, and the straight regular structure will break and melt, turn into a liquid structure. On further heating, the now liquid substance expands more and the distance between particles are very far apart. Some particles at the surface gain sufficient energy to overcome the intermolecular forces and evaporate, turn into gas. On the other hand, when a gas is cool, the particles lose energy. As the result, the particles will move closer to each other and turn into a liquid structure. On further cooling, as the temperature decreases over time and reach its freezing point, the particles can only vibrate in fixed position, and that's how a solid is formed. Now let's talk about the heating curve. Heating curve shows how the temperature of a substance changes as it is heated over time. Please remember that below melting point is a solid state. Between melting point and boiling point is a liquid state, while above boiling point is a gas state. Let's take pure water as an example. As we all know, the boiling point of water is 100 degrees Celsius. And the melting point is 0 degrees Celsius. So at room temperature, which is about 20 degrees Celsius, the state of water is going to be liquid state because the melting point is at this part below, which is 0 degrees Celsius. And the boiling point is at the top, which is 100 degrees Celsius. So 20 degrees Celsius is still in the range of 0 to 100 degrees Celsius. But if you take the water and put it in a place which temperature is below 0 degrees Celsius, let's say you put it at minus 5 degrees Celsius, the water itself will turn to ice, which is solid state. So if you take the water in room temperature or any temperature start from 1 to 99 degrees Celsius, then it will change to liquid water and we can drink it. And above boiling point, let's say you take the water to a very hot place above 100 degrees Celsius, then it will turn into a gas. And this is what we call water vapor. Now let's talk about pure substance. Pure substance will have a sharp or fixed melting point and boiling point, while impure substance will have the melting point and boiling point over a range of temperatures. Let's take one example of pure water here. We know that pure water have melting point of 0 degrees Celsius and boiling point of 100 degrees Celsius. So that means it only have one fixed and exact value. This value can be measured by using thermometer. On the other hand, if you put some salts into the water, so the water is contaminated by salt, or we can say that the water become impure now. When salt is added to water, its melting point decreases. The more salt you add, the lower the melting point becomes. For example, it becomes -1, -2, or -3 degrees Celsius. The same thing also happens with the boiling point. When salt is added to water, its boiling point increases. The more salt you add, the higher the boiling point becomes. For example, it becomes 101, 102, 103 degrees Celsius. Or I can say both the value of melting and boiling point become in range, not a single fixed value anymore. Now let's talk about the effect of pressure and temperature of a gas in a closed container. So note that the pressure of a gas comes from its particles colliding with the walls in a container. An increase in temperature increases the kinetic energy of each particle, as the heat energy is transformed to kinetic energy, so they move faster. As the temperature increases, the particles in the gas move faster, impacting the container's walls more frequently. The pressure that a gas creates inside a closed container is produced by the gaseous particles heating the inside walls of the container. So the conclusion here, we can say that if there is an increase in temperature, this also causes an increase in gas pressure. Now let's talk about Brownian motion and kinetic particle theory. Brownian motion is the random movement of particles in a liquid or a gas produced by a large number of collisions with smaller, often invisible particles. Imagine you drop a tiny bit of dust into a glass of water. Even though the water looks still, the dust keeps moving around in a random, zigzag way. That's because the invisible water particles are constantly bumping into it, pushing it here and there. That random jiggling around is called Brownian motion. While kinetic particle theory stated that matter is made up of very small particles that are in constant motion, everything around us, water, air, even solid objects is made of tiny particles which is too small to see. These particles are never still. They are always want to move. Now let's see about diffusion. So this picture shows the diffusion process of a liquid. Note that diffusion is the process by which different gases or different liquids mixing together due to the random motion of their particles. Diffusing particles move from an area of high concentration to an area of low concentration. For example, in this picture, you can see there is a drop of thick purple liquid. Since it is very thick, so it contains of high concentration of purple liquid. And when it drops into a water, it will start to diffuse, spreading from area of high concentration to an area of low concentration over time. At the end, the concentration of particles is even as they spread out to occupy all of the available space in the beaker. Remember that diffusion happens on its own and no energy input is required, although it occurs faster at higher temperatures. It is just the natural movement of particles from high concentration to low concentration place. It happens automatically without using energy, but if the temperature is higher, the particles move faster, so diffusion happens more quickly. Now let's see how is the effect of temperature towards the rate of diffusion. So please take a look at the picture here. Imagine if I have 2 cups of tea with sugar cube. The first cup is using hot water, while the second cup is using cold water. If I put the sugar cube, which sugar cube will diffuse faster in the tea? Is it by using hot or cold water? Yes, the answer is the sugar cube will diffuse faster in the hot water. This is because increasing the temperature of tea will also increasing the kinetic energy of particles. As the result, the particles will vibrate even more, move faster and further apart, so the rate of diffusion will also increase. Let's take a look at this example of diffusion. If you have milk and coffee, then you mix them together, what it will become? Yes, they will become coffee milk. The particles of milk and coffee mix together on their own until you get a delicious glass of coffee milk. That's diffusion between liquids. Easy, right? Now here's another one. Imagine someone farts. Yeah, not so nice. At first, the smell is really strong for the person standing nearby because that's where the concentration of gas particles is the highest. But very quickly, those particles start spreading out into the air, moving from area of high concentration to low concentration. And that's why even people sitting farther away will eventually smell it, just not as strongly. So that's diffusion between gases. The particles of the bad smell spreading through the air. Then what about solid? For example, if you have a pencil and eraser sitting next to each other, can you mix them by themselves? Nope. Solids don't diffuse into each other under normal conditions. This is because in solids, the particles are packed very tightly together and they can only vibrate in place. They don't have the freedom to move around like in liquids or gases. That means the particles of the pencil will stay in the pencil and the particles of eraser will stay in the eraser. No mixing at all. The only way solids can mix is if you heat them to a very high temperature until they melt and turn into a liquid structure. Then you quickly mix them together before they cool down and turn back into solid again. Note that diffusion occurs much faster in gases than in liquids, as gaseous particles move much quicker than in liquid particles. But at the same temperature, different gases do not diffuse at the same rate. This is due to the difference in their relative molecular masses. Lighter gas particles can travel faster and further. Therefore, the lower its relative mass, the faster a gas will diffuse. Now let's discuss about the effect of molecular mass towards the rate of diffusion through this illustration. Imagine a running race. On one side, there is a man with a mass of 65 kg, and on the opposite side, there is another man with a mass of 110 kg. Who do you think will run faster? Of course, the man with a mass of 65 kg can move more quickly, while the man with a mass of 110 kg runs more slowly. Because of this, when they both start running toward each other, they won't meet exactly in the middle of the road. Instead, they'll meet at a little closer to the right side. So that illustration can explain the experiment between ammonia gas NH3 and hydrogen chloride gas HCl in a closed gas tube. The mass of ammonia gas is 17, while the mass of hydrogen chloride gas is 36.5. Since ammonia gas is lighter than hydrogen chloride gas, then ammonia gas will travel faster and further. Both gases will diffuse and form a white smoke of ammonium chloride gas NH4Cl closer to the right side of the tube. So yeah, that's all about this topic, states of matter. We will discuss about some past paper questions in the question and answer section. Thanks for watching. Don't forget to like, comment, and subscribe. See you again.